welcome back. Today we'll see what is multi-threaded programming. Java provides built-in support for multi-threaded programming. There are two kinds of multitasking. So we all are acquainted with multitasking because it is supported by virtually all modern operating systems. There are two kinds of multitasking: process-based multitasking and thread-based multitasking. So we'll see what is process-based multitasking. A process is a program under execution. Process-based multitasking allows a computer to run two or more programs concurrently or parallelly. So example is you can run Java compiler at the same time that you are using text editor or visiting a website or listening to music. All these are done in parallel. So it is process-based multitasking. A program is the smallest unit of code that can be dispatched by the scheduler. Processes are heavyweight tasks that require their own separate address spaces. Inter-process communication, IPC, is expensive and limited. Context switching from one process to another is also costly. Okay, costly here means that excessive or indirect utilization of the resources, time, bandwidth, memory, all that is called as overhead over here. So let us understand what is thread-based multitasking. A multi-threaded program contains two or more parts that can run concurrently. Each part of such a program is called a thread. Okay, so threads are part of a program. And each thread defines a separate path of execution. A single program can perform two or more tasks simultaneously. For example, a text editor can format text at the same time that it is printing or it is saving. So all these things happen simultaneously. As long as these two actions or these three or four actions are being performed by different or separate threads. A thread is the smallest unit of code that can be dispatched by the scheduler. Threads are lightweight. Threads share the same address space. ITC, inter-thread communication, is inexpensive compared to IPC. Context switching from one thread to next is lower in cost. So what are the advantages of multi-threading? The advantages of multi-threading are: multi-threading enables us to write efficient programs that make maximum utilization of processing power available in the system. So one important way multi-threading achieves this is by keeping idle time to a minimum. This is especially important for the interactive network environments. Multi-threading allows animation loops to sleep for a second between each frame without causing the whole system to pause. Java's multi-threading feature works in both single-core and multi-core systems. In a single-core system, concurrently executing threads share the CPU. Like CPU mimics like it is concurrently executing, but context switching happens between the threads. In multi-core systems, it is possible for two or more threads to actually execute simultaneously. So what are the different ways of creating a thread? There are two ways of creating a thread. One is implement the runnable interface. The second is extend the thread class itself. How to create a thread implementing runnable interface? The first thing you need to do is create a class that implements runnable interface and need only to implement a single method called run. In runnable interface, there is only one method which is public void run method, and this class need to implement the run method. So what is this run method? Inside run method, you will define the code that constitutes the new thread. Run is the entry point for another concurrent thread of execution within our program. The thread will end when run returns. So the entry point is the run method and the exit point is when the run returns. Instantiate an object of type thread from within that class, the class that implements the runnable interface. The thread constructor that we will use is thread, runnable thread object and string thread name. Thread object is an instance of the class that implements the runnable interface. The name of the new thread is specified by the thread name. After that, we have to call the start method, which is declared in thread class, and in turn this start method executes a call to run method. So what will happen if I don't use a start method and directly call the run method? If I don't use start method and call directly the run method, no new thread will be created. Run method will be like every other normal methods that a class will be having, and the run method will execute. It will not give you an error. Run method will execute, but no thread will be created. So it is very important for us to use the start method, and through start method only the run method will be invoked. That is where your new thread will be created. So with this idea of how to create threads using runnable interface, let us see the program.